Hi, welcome to the video. This is the 2017 Numeracy November papers. This is paper 2 and it's just the higher A and A star work. So on the higher paper that was question 5 onwards. Question 1, 2, 3, 4, they were on the intermediate paper. If you're looking for answers for those, have a look for my intermediate video there. They'll be on the end, the last couple of questions. This is just the higher sections, no point doing it all twice. Okay, so number 5, this is a compound interest question with multipliers, and it's a bit different because you have to find the power yourself. Okay, but if we sort of put the basic calculation in, she's got 7,500 as her initial starting amount. The interest rate is 0.31, so you have to do 100 plus 0.31, which is 100.31. That's a percentage. To make that a multiplier, you've got to divide by 100. So your multiplier is 1.0031. Now that's very easy to get wrong. And then you've got some power, and we're aiming to get, I won't put an equals because it's not going to come out equal, but we're aiming to get more than, and we're going to keep going until that goes over £8,000. Okay, all you've got to do now, once you've got this set up, is to muck around with that power, put in various numbers in. Okay, if you put the power of 20 in, it comes out really close, £7,978-ish. Okay, so that's not enough. The first time it goes over £8,000 is when the power is 21. So when you get to the power of 21, that actually comes out as £8,003. and 69p. Now you're not going to want to do that year by year because you spend the whole paper just going through one question, so make sure you're familiar with multipliers. So 21 months basically is the answer for that, and if you use multipliers it's quite quick to do. You just trial and error until you get over £8,000. Make sure you don't stop short. Okay. Number 6, this is trigonometry and bearings and speed, distance, time all in one question. So if you've got a weakness on any of those, it's going to really affect your ability to answer this question. So the ship starts from Mulk, okay, and it says that the bearing to get to Lindat is 211 degrees. So a bearing is measured from north. So there's my north arrow on Mulk, so that's where the boat starts. And we're told that that bearing there is 211 degrees. Which in itself is useless to us because it's not in the triangle, but it does mean that we can work out that angle there. Okay, remember if you went from north round to west, that's 270 degrees. So this is 59 degrees. Okay, once you know that's 59 degrees, remember we've got a right angle up in this top left corner. You can also work out that that bottom angle down there is 31 degrees. But unless you're familiar with bearings, you're not going to be able to get the 59 or the 31, and then you're going to be stuffed for the rest of the question. We've also got some distances. So Lindat is 24 kilometres due south of Newark, so we've got a 24 kilometres. So we've got one side, and we've got, well, a choice of angles. So you can do this with sine or cos, depending on which angle you pick. Now we're trying to work out the hypotenuse because that's where the boat's sailing from Mulk to Lindat. Okay. Now your options are, if you use the 24, you need to use sine. So h equals 24 over sine 59. If you choose to use the 31 degree angle, it's cos, and so it's 24 over cos 31. But either way, the hypotenuse comes out as 27.9992 basically, or 28 kilometres if you want to make life easy for yourself. Okay, so our distance the boat has to travel is 28 kilometres. Now we've got to go, so we've done that. Now we're down to the speed bit to work out the time. All right, time is distance over speed. We're working in kilometres and kilometres an hour, so that's good. There's no converting to do there. We need to do 28 kilometres over 28 kilometres of an hour. That gives us 1.4 hours. Be very careful here. That doesn't mean 1 hour 40. Okay. When you're working with decimal time, 0.1, I'll put this in a little box over here. 0.1 hours is 6 minutes. because it's 1/10 of an hour. Okay, 10% of an hour is 6 minutes because an hour is 60. So 1.4 hours is actually 1 hour and 24 minutes, not 1 hour 40. Okay, be careful. Now the ship left at 11:45. So if you add on an hour and 24, what you get is 1:09 in the afternoon, 1:09 p.m. or in 24-hour time, 13:09. Alright, that's quite tricky. If you got 31 or 59, that was a mark. If you're using sine or cos properly, that got you another 2 marks, and then the answer was a 4th mark. So this was 4 marks, just getting to here. And then the other 3 marks then were for doing the speed, distance, time calculations and adding the time on at the end. Question 7 then. This goes into AER later on, which is not on the 2021 syllabus, but it may well be back in 2022 if you're watching this sometime in the future. First question is to calculate the nominal interest rate. In other words, how much interest are you getting in 1 month, sort of a standalone if you like, or over a year but based on monthlies. So you can see here you get £14 interest on £2,800 of initial money. So what you need to do is 14 over 2,800 and then times by 100 to make it a percentage. So that comes out as 0.5%. Now that's per month. Okay, I'm using that amount of interest compared to that amount of money we started with. So £14 is 0.5% of 2,800. So it's 0.5% per month. Now the nominal interest rate per annum means very simply just times that by 12. Now we know it doesn't work like that, but that's why the nominal interest rate is stupid. So 0.5 times 12 gives you 6% per year. Alright, this is the nominal interest rate. Right, if you actually do this properly, you need to convert that to an AER, don't you, which is the second part of the question. So to calculate AER, the formula is on the front cover. It's 1 plus I over n to the power of n minus 1. I is the nominal interest rate as a decimal. N is the number of payments per year. So feeding in the numbers from above then. So it's 1 plus 6% as a decimal, 0.06. Paid monthly means 12 payments per year. To the power of 12 minus 1. You get an AER of 6.17%. Alright, it'll come out as 0.0617 when you use your calculator, but that's still in decimal form. So times it by 100 to get it as an actual percentage. Remember, the AER will always be slightly above the nominal interest rate, not much. So it shouldn't be too difficult to convert 0.061 into 6.17% when you already know the nominal rate is 6%. So that's question 7. Question 8 is arcs and sectors to begin with. Okay, so our first job on this question is to calculate, that edge there, okay, in red, which is an arc. And the arc has got a 20-degree angle and a 10 centimetre radius. So your first job is to do 20 over 360. Now it's arc length, so it's pi times d, or 2 times pi times r. So I'll do pi times d. The diameter of this cake would be 20 because the radius is 10. And you get an arc length of 3.5, okay, or 3.49 to be inaccurate, 3.49 centimetres. Then you've got to work out this sort of dark black diagonal strip, and the key to that is to imagine it not being a curve but being flattened out, like you could cut a cardboard toilet roll and flatten it to a rectangle. Okay, all arcs in 3D can be flattened to a rectangle. Now if I drew that rectangle out, we know the top of it is 3.49 centimetres, we just worked that out. We also know the height of the rectangle is 4 from the depth of the cake. And then the black strip, which is curved, when it's flattened, is actually just a nice straight line that goes from corner to corner like that, and it's the same length when you flatten it as it is when it's curved. So this is Pythagoras then, and it's adding Pythagoras. It's 4 squared plus 3.49 squared gets you a diagonal length of 5.3. Okay, 5.3 centimeters. Then it says that that's going to be done on all of the slices. Now, if every slice is 20 degrees, a full cake is 360 degrees. How many slices would you have? How many 20s are in 360? That'll be 18. So to get the total length of icing, you need to multiply that by 18. And so the total length for the last 2 marks, you get about 95. Well, it's between 95.4 and 95.8. It depends on your rounding. It's around 95.6 centimeters. Okay, depends on how accurately you rounded. Number 9, sampling. Okay, again, not on the 2021 syllabus, but could well be back in 2022. So, all about random sampling and stratified sampling is. Choosing every 4th person on an alphabetical list is a simple method of randomly choosing the office staff required for the sample. That is false. Okay, anytime you're following a rule, it can't be random. And if you're following every 4th, that is systematic. So systematic and random, they can't happen at the same time as one or the other. Numbering the cleaning staff, placing numbers in a hat and drawing numbers out is random. That is random. Okay, because you're drawing the numbers out of the hat and you could get anything. Doing a stratified sample calculation, which is 9 out of 85, which is 85 workers, and it's a sample of 15 equals 1.59. This means there will definitely be 2 managers. Without going too much into it, when you do stratified sampling, you don't always stick with the numbers you get on the calculator. So normally 1.59 does round up, but it can happen that you end up with too many people in your survey if you do that. So if that happens, what you do is you'd go back through your numbers and you'd find the one which was closest to 0.5 and round it down. So if 1.59 was the closest to halfway, 1.5 in other words, you might actually round that down to 1 if you had too many people overall. You need to be quite familiar with stratified sampling and have done some questions to understand what I'm on about there. But if you've done some questions, you'll have seen ones where sometimes, even though a number should round up, sometimes it rounds down. So that's false. You can't definitely be sure it's going to round up to 2. And because you do rounding in stratified sampling, so we said that's either going to round to 1 or 2, then it will never be exactly the same as what it should be. Okay, you can't pick 1.59 people, so you pick 1 or you pick 2, and then obviously that's either too many or too few really, so it's never exactly the same. You just get as close as you can. Now you've got to pick numbers from a random number list. So there's 50 engineers. Because 50 is a 2-digit number, you split these into 2-digit numbers and you either say yes or no depending on whether they're above 50 or below, and we've got to do this to get 9. So the first 2 numbers is 29, so that's a yes. Then you've got 97, which is a no. Then you've got 45, which is a yes. Then you've got 54, which is a no. Then 79, which is a no. Then 07, that's a yes. And you work your way across the list. Now be careful because there's a 24 there and we already had a 24 next there. So be careful you don't double up on your 24s. The 9 you should end up with is 29, 45, 07, 24, 39, 17, 03, 49 and 12. Now it says to describe clearly how you're doing it. So you would have to say that you numbered the engineers from 1 to 50, that you're going to split the random number table into numbers in 2s, 2 digits at a time, because 50 is a 2-digit number, that you're only going to pick numbers between 1 and 50, and you're going to ignore any repeated numbers, and we did have a repeat. Okay, so you'd need to say all of those things to get the explaining marks, because in this question it's 1 mark for picking the right engineers and 2 marks for the explaining. So make sure you explain fully how you did that. Then 9C, which is completely unrelated to the one before, so I don't know why it's not just called question 10, is to guarantee having enough paint to paint all surfaces on this building. Now, if you want to guarantee having enough paint, you have to assume that the building is big. Because if you buy enough paint to paint a big building, you'll have enough paint if it turns out to be a little bit smaller. So for each of these numbers, we need the upper bound. Okay, so that is, for this number, 24.5, because it's rounded to the nearest metre. Okay, 43.5 for that one. Now the tins of paint, we're not there yet, but for the tins of paint we'll have to assume that they're small tins of paint, because that's the worst case scenario. Quite often with this we're on the worst case scenario, aren't we? Okay, right, then it's a case of using your formulas off the front cover. So if we start with this curved end piece there, now it takes a bit of imagining, but that's actually 1/4 of a sphere. The formula for surface area of a sphere is 4 pi r squared. Alright, so you can either do 4 pi r squared and then divide by 4, or you could just do pi r squared, because you can divide by 4 anyway. But be really careful, because it's radius, not diameter, and so the radius is actually 12.25. So it's going to be 4 times pi times 12.25 squared, but then divided by 4 because it's only 1/4, and that's 471.6 meters squared. Okay, of area. Then you've got the curved sort of main body of the building there. Now that's 1/2 of a cylinder, the curved surface area of a cylinder. When you fold a cylinder out, okay, pi d is the old circumference and h, and we've got 1/2 of that. So if this was sort of turned upright like a toilet roll, there's your h, there's your diameter, so it's pi times d times h, but divided by 2, because we haven't got a full cylinder, we've got 1/2. It's like 1/2 of a cardboard toilet roll. So using our upper bounds is pi times 24.5 times 43.5, and then all of that divided by 2 gives 1,673-ish, 1,674. Okay, meters squared. And then the last surface to paint is this one here, which is 1/2 of, we painting that, let's have a look, yeah, 1/2 of a circle, so pi r squared divided by 2, so pi times, again be careful because it's r not d, so 12.25, pi times 12.25 squared divided by 2, and that gives us, well, it gives us a total, because I'm working off the mark scheme here, a total surface area of 2379-ish, or 2380, let's call it, meters squared. Okay. Then how many tins of paint do you need? So it's 2,380, which is the biggest surface area, divided by 39.5, which comes out as just over 60. Okay, 60.2 tins of paint. So you would need 61 tins altogether, because 61 tins is considering that the tins are smaller, the area is bigger, so that is the most that you could possibly need. If you buy 61 tins, you will definitely have enough no matter what happens.